I was pretty skeptical when I got this printer out of the box. Bambu Lab has made some odd choices with this one, but the more I use it, the more I think I understand what they're going for here, and especially at this price point, I think this is going to be pretty compelling for a lot of people. Let's talk about it. Welcome back to Cloud42, I'm James. This is the new X2D from Bambu Lab, and as you can guess from the name, it's the successor to the X1 Carbon, and it's positioned in the middle of the Bambu Lab lineup, somewhere between the P2S and the larger H2 series machines that I've reviewed previously. I've had the printer since sometime in January, and I put a couple hundred hours on it, actually using it for projects I'm working on in the shop. I also reran some parts from previous projects to test how it handles the kinds of work that I do every day. And I also ran some tests to push the machine into areas that Bambu Lab doesn't recommend, just to see how it would handle it. Bambu Lab has a long history of under-promising and over-delivering, so when they say not to do something, I'm going to try it. So what exactly is this thing? The X2D is the new flagship standard size printer following in the footsteps of the X1 Carbon and more recently the P2S. It has the same 256mm square build volume as those printers, and it's physically the same overall size package. It has a 350-degree hot end, 120-degree heated bed, and a 65-degree heated chamber, so it's able to print engineering-focused materials like ABS, ASA, nylon, and PET better than the X1 or the P2. It also has HEPA and activated carbon filters, and it uses the same AMS2 Pro and AMS-HT units as other recent Bambu Lab printers. It has the new servo-driven extruder and bajillion sensors that they've incorporated into all of their other recent printers, and they even have a vision encoder plate sized for this machine, so you can do the same camera-assisted calibration of the mechanics as its bigger siblings to ensure that prints come out square and on size. They also managed to cram a second nozzle into the same package without reducing the size of parts you can print, though there are some caveats that we need to talk about and some things that you should be aware of if you're thinking about buying one of these. The base printer is priced at $649 in the US, with the AMS combo going for $899. As of today, that's only $100 more than the P2S, and that money gets you a heated chamber and a second nozzle. It also makes it about half the price of the H2S and well under half the price of the H2D. That pricing is way more aggressive than I was expecting, but I'm pleased to see it. And don't worry, we're still going to talk about that second extruder. Before we jump into my thoughts, you should know that Bambu Lab sent me this printer free of charge in exchange for providing early feedback to them about it. I get to decide if I want to show it on the channel. They have no control over what I say, and they're seeing this video the same time you are. There's also a link to purchase one down in the video description, and if you use that, it helps support the channel, but it's totally up to you if that's something you want to do. I get a lot of, let's call it uncomplimentary feedback about these disclosures in my review videos, but if you're going to listen to what I say, you need to know about my incentives, and I don't know a better way to make that happen than to just tell you. Oh, and if you haven't seen one of my reviews before, first of all, welcome. I don't tend to approach these things like a tech journalist. I really don't care very much about all the fancy new features, and I all but ignore the product briefs. I just want to use the printer. It's a tool, and if it does what I need with a minimum effort for a reasonable price, it's a good tool. I haven't seen anybody else's reviews yet, but I am willing to bet that the primary discussion is going to be about the second nozzle. And that's fair because it's different. Instead of putting a dual direct drive extruder in the tool head of the printer, Bambu Lab decided to put a Bowden extruder on the back of the printer to drive the second nozzle. Yeah, it's 2026 and they just shipped a printer with a Bowden extruder. They're not positioning it as a true general purpose dual extruder printer. They're positioning the second nozzle as an auxiliary extruder for printing support material. Because the Bowden extruder has to push filament through a long tube, it's going to compress and expand, especially with less rigid filaments, so it requires longer retractions and it can't print as fast as the primary direct drive extruder. The slicing software knows about this and the profiles are tuned for it, but there are going to be some necessary performance compromises because of the mechanical limitations. In fact, they have a whole list of things that you should not do with the auxiliary extruder. You shouldn't use it for the primary material of a print. You shouldn't install a 0.2 millimeter nozzle, and there's a whole list of materials that they don't recommend printing in it. I, of course, tried all of those things, and I'll show you the results in a bit. It's not fully awesome, but it is more capable than they claim. So, what do they intend for you to do with the second extruder? They say it's primarily intended for support material. You can, of course, print breakaway or dissolvable support with a single nozzle printer, but if you've ever printed PETG with a separate support material, you know that it's almost impossible to completely purge out all of the support when the printer switches back to PETG. No matter how much you purge, there always seems to be just a little bit of residue in the hot end. That mixes into the PETG and it creates a weak layer in the print. I've had several prints break in half right at that support interface layer because of that contamination. Having the support material in a different hot end solves that problem, and some reduction in the print speed for the support interface doesn't really have much impact overall because there typically isn't a lot of volume in the support interface. Now, the Bowden architecture does allow them to keep the toolhead small and light, which improves overall print speed and quality, and you don't have to give up a bunch of print area like you do on their larger dual extruder printers. The primary direct drive extruder can still reach the entire 256 millimeter square bed, and only the auxiliary extruder has a strip down the left side of the bed that it can't reach. They've also switched to a mechanical bump lever to raise and lower the auxiliary hot end, which eliminates a motor and further reduces the mass of the tool head. The Bowden extruder and the filament buffers are mounted on the back of the printer. The instructions tell you to plug the AMS into the primary extruder, and the printer comes with a short tube to connect the auxiliary extruder to the external spool holder. They even supply different colors of PTFE tubes to keep everything straight. But you don't have to do it that way. You can switch it around so the AMS is on the auxiliary extruder input, and you can even connect multiple AMS units to both extruders if you want. The printer supports automatic AMS discovery just like their other printers. You just put a roll of filament in each AMS and it feeds it into the printer to see which sensors are triggered, and it configures itself. You can also bypass the buffer entirely to feed TPU into the primary extruder, which I did during my testing. I did not try printing TPU in the Bowden extruder, so technically I can't prove it won't work, but I believe them when they say it's a bad idea. Functionally, the nozzle switching cycle looks similar to the one on the H2D. The right nozzle moves up and down, and there's a flow blocker that moves back and forth to plug the nozzle that isn't printing so it won't ooze on the print. When switching, it preheats, toggles to the other nozzle, and it primes on the prime tower before continuing. It doesn't need to purge, so waste is reduced just like on the H2D and H2C, though you can still use the AMS to swap filaments and purge as much as you like. The printer has the same nozzle wiping and cleaning and automatic nozzle offset calibration as the H2 series machines, and the hot ends themselves are interchangeable with the bigger printers, but there are a couple of differences. First, the printer can't actually tell which size nozzles you have installed. The H2 machines can use the chamber camera to read the markings to figure it out, but the X2D requires you to configure the nozzles using the touchscreen. And second, there isn't a motor to switch nozzles in the tool head. Instead, there's a lever on the bottom, and the printer actuates this lever against a hard point in the back of the chamber to make the switch. I actually kind of like that because you can easily reach under the head and toggle it when you're installing nozzles, so it's much quicker than using the touchscreen. That's enough jabbering. Let's look at some prints. This is the custom toolbox badge I have on all of the boxes in my shop. It prints face down on the bed and it uses 3 filaments. These are all Bambu Lab filaments: Silver Silk PLA Plus and Red and Black PLA Basic. The first layer is pretty much perfect, which is what I've come to expect from Bambu Lab machines. The edges are clean and there aren't any gaps. The spaces between the letters are bridged, and that's also pretty clean. In this case, I had all of the filaments in the AMS attached to the main extruder. I printed another batch with support under the bridging using Bambu Lab support for PLA in the auxiliary extruder. The auxiliary extruder laid down nice, clean support interfaces that removed easily. The support for PLA is actually pretty soft and flexible, and I wasn't really sure how it would perform in a Bowden extruder, but they apparently have it tuned pretty well because it laid down nice and flat and the support came off easily. When the support isn't perfectly smooth, it often gets embedded into the print, making it hard to remove, but this came out pretty clean. Personally, for this part, I prefer the look of the bridges. They're less perfect, but they look darker, which is kind of better for the spaces between the letters on a badge. But my main use case for a printer like this is to use the heated chamber to print engineering materials. So let's jump straight to nylon. This is an enclosure for a power test fixture that I designed about a year ago. It's printed in Bambu Lab PAHT carbon fiber. This prints with the chamber at the full 65 degrees, and I typically use Bambu Lab glue stick on the bed sheet to get it to adhere well. This is printed with a 0.4 millimeter nozzle and 0.2 millimeter layers, and as you can see, it looks every bit as good as the ones I printed on the H2D. This part is getting to about the size where even reinforced nylon materials start to curl in the corners, but with the heated chamber, this stayed nice and flat. I live in a pretty dry climate, but I still find that I have to dry this material, but it dries well in the AMS HT. Pushing the temps a little higher, I printed this stealth burner extruder body in Bambu Lab PPA CF. This is again just a single material print using the primary direct drive extruder and the heated chamber. This material prints well in every Bambu Lab printer I've tried it in, and the X2D is no exception. Takes a few minutes for everything to reach temperature since we're close to the maximums for the bed, the chamber, and the hot end, but once the machine preheats and runs the high temperature bed leveling, it prints beautifully. You do have to bypass the buffer and feed directly into the port on the printer because this material is incredibly rigid. Trust me, you don't want a little piece of this stuff broken off in the buffer. If you've seen my other review videos, you've seen this part before. This is a housing for the VFD controls for a drill press conversion project that is actually still waiting for me to finish it. This is printed in black and blue ABS glass fiber. It also has a support interface layer in there somewhere. The black is printed using the direct drive extruder, and the blue is printed with the auxiliary extruder. They don't recommend using the auxiliary extruder for major body colors, but I did it, and at least with ABS glass fiber, it looks great. This is another material that seriously benefits from the heated chamber. You can print in a passively heated printer, but depending on the size and part geometry, there's a point at which it starts to curl. If I had to nitpick, I think maybe the fill level and the quality of the sharp corners at the edges of the blue areas aren't quite exactly the same shape as I remember in previous tests, but honestly, it's pretty good. And just to see if it made any difference at all, I reprinted it with the black in the auxiliary extruder and the blue in the primary, and I really can't see any difference. I wrote on the bottom which one is which, but without that, I don't think I'd be able to tell. I was definitely able to tell the difference in speed though. Grouped the way they recommend, it took 9.5 hours. Grouped the other way, it took 14, just because the body was being printed at a lower flow rate because it was being printed in the Bowden extruder. To be fair, there's a lot of both colors, so both are affected by the slow extruder. And for comparison, the print would have taken about 11 hours if you just printed it with one nozzle and accepted the purge waste. Here's another multicolor test print. The main body here is printed in Bambu Lab black ABS glass fiber, and the white is Bambu Lab ABS. The white is in the auxiliary extruder, and it's much more exposed here, both because it's white and because it doesn't have fiber reinforcement to hide the layer texture. But I think it looks great. I would use this. In fact, I will use this. You will see this in a future video. I also tried printing TPU with PLA support. This is a short test version of the bellows that I made for my milling machine. This is something that you can't do at all in a single nozzle printer because there's no way to run the TPU in the AMS. This is Bambu Lab TPU 95A HF, and the support is Bambu Lab PLA Basic. I printed the TPU in the primary extruder, bypassing the buffer and feeding directly into the printer. The PLA was in the auxiliary extruder, and it printed fine. The print is, of course, slower than in the H2D, which has 2 direct drive extruders, but this printer can certainly handle it. These are the flexi pliers that I have also used in previous tests. The center flexure is printed in the same 95A TPU, and the handles and jaws are printed in Bambu Lab PETG HF. The two materials are geometrically interlocked at the interface where they connect, which can be a little bit challenging because of all the thin layers in alternating materials. There's lots of opportunity for the print to adhere funny and gum up, but this printed pretty well. The only complaint that I have about this print is that the end of one of the handles lifted off the bed. This is something that the PETG HF is prone to do in my experience, and the geometry of this part is particularly susceptible. It has long continuous loops around the perimeter with very little contact area for bed adhesion. I have a grandson, and it turns out he likes articulated dragons, so I printed one. This is Bambu Lab PLA Basic, and while designs like this are massively overplayed on every marketplace on the planet, they're also a pretty good test of filament control and retraction. This print has a bazillion little islands, and it turned out well. I'd be proud to give this to my grandson, and I probably will as soon as I'm done recording this video. This is a set of radius gauges printed in 2 colors of PLA Basic. The purple was printed in the primary nozzle, and the white was printed in the auxiliary nozzle. The lines are clean, there aren't any gaps, and everything is clearly legible. I think this is actually a pretty good application for multicolor printing because the geometry is simple and the volume through the auxiliary nozzle is low, so it doesn't slow down the print too much. These are printed with 0.4mm nozzles, which is as small as they recommend going with the auxiliary extruder. But of course, there isn't really anything stopping us from trying 0.2, except maybe good sense. This is the same model as the larger Dragon, but printed at half size with 0.2mm nozzles at 0.8mm layer height. The purple is printed in the primary extruder, and the red is in the auxiliary. And as you can see, the difference is night and day. The purple is clean with smooth surfaces and fine details, and the red is kind of a mess. To be fair, this is kind of at the limit of what you should expect an FDM printer to be able to do at this scale. And while the primary extruder did a very nice job, the auxiliary extruder did not handle it well, which is exactly why they tell you not to do it. So let's do it again. These are labels for Gridfinity storage boxes. They're printed with 0.2mm nozzles at 0.1mm layer height in PLA Basic, with the white in the auxiliary extruder. And again, they're not great. The printer is really struggling to control the tiny volumes of white material in the auxiliary extruder, which is kind of to be expected with high back pressure and long retracts. This one was printed on the H2D with the same settings, but with a dual direct drive extruder, and the quality is much better. And finally, if you follow the channel, you have seen this test fixture that I made for the GPS clock project. The main fixture body is printed in Bambu Lab PLA Basic, and the wheels are printed in black and white PLA Basic. The body's printed with 0.2mm layers, and the wheels are printed with 0.1. I used the auxiliary extruder for the white, and it looks okay. It's not amazing, but it's serviceable. This print has lots of little white islands with very low flow volume and lots of retractions, so it's gonna show more of the limitations of the Bowden extruder. So is the print quality bad? Is it good? How do we summarize this? I really don't think you should think of this as a dual extruder printer. It's more like a 1.5 extruder printer. It's a very capable single nozzle printer with a heated chamber that does a fantastic job with engineering materials, and it has an auxiliary extruder that's best suited for small amounts of support material. It can also handle TPU with PLA support, which is something that a single extruder printer can't do at all. And as I've shown, you can get good results with contrasting colors in the second extruder for PLA, PETG, and ABS with 0.4 millimeter nozzles and 0.2 millimeter layers. But I wouldn't go out of your way to buy this printer specifically for that use case. The X2D, of course, uses the same Bambu Studio and Bambu Handy apps as the other printers in the Bambu Lab ecosystem. They've updated the slicer with knowledge about the Bowden Extruder in the X2D, and it does its best to steer you to combinations that will yield good results, though, as I've shown, it will still let you try things that are not recommended. The printer is cloud connected, just like all Bambu Lab printers. I am aware that opinions vary, but I personally would not want to operate without the features that the cloud connectivity provides, like remote monitoring and especially firmware updates. Some people have very strong feelings about, well, everything, but in today's security threat landscape, I just cannot imagine running any smart device even in local-only mode without firmware updates. The time window between vulnerability discovery and active exploitation used to be days, and now it's hours. So I want security updates as quickly as possible. Even with that, though, I keep smart devices on an isolated network segment that can only communicate out to the internet. So if, or more likely when, one of them gets compromised, there's a barrier between it and more important things on my network. I've been running this and all of my other Bambu Lab printers in that configuration for months, and everything still works, including job submission and viewing the camera feed. So, well done, Bambu Lab. I know there are people out there saying to never update firmware on a device that's working, and they're welcome to do that, but just because they're playing with matches and running with scissors doesn't mean that you have to too. Someone will also ask if it has an Ethernet port, and it does not. It's Wi-Fi only. So should you buy one? As usual, that's entirely dependent on what you want to do with the machine. If what you really want is an X1 carbon or a P2S with a heated chamber so you can run engineering materials, this is exactly that. It's fast, it's smooth, it's quiet, and in my testing, it just worked. I never touched any of the presets for anything. What it comes out of the box with worked for me. I added perimeters to prints where I needed strength and configured support when I needed it, but otherwise I just let it do its thing. The auxiliary extruder is also a benefit over the X1 or P2, but it's really best used just for support and for minor contrasting colors in prints that aren't technically challenging. It's a great option to have, but it probably isn't by itself a reason to upgrade if you don't want or need the heated chamber and you aren't struggling with support material today. Now for me, the heated chamber alone is reason enough to spend the extra $100 over the P2S, and it's the one feature that I really missed when I had my X1s. Now you should also think about the size. I've grown pretty accustomed to having the larger printers here over the last year. My daily drivers are the H2D and the H2C, and I found the smaller printer a little bit limiting for the kinds of things that I print. I had several projects during testing that I just could not print on this machine because they wouldn't fit. But if you're thinking about making the jump up to the H2 machines, keep in mind that they not only cost a lot more, they're also big and they are heavy. They take up more space. You'll want a second person to help move them around, and they use more power. So sometimes less is more. At this point, I think I'm going to update my recommendations. For people just starting out who have no idea how much they'll use a printer, I still think the A1 or the A1 Mini are great for dipping your toes in the pool without spending a lot of money. And for power users who know that they'll be printing big parts with lots of colors or multi-material prints with TPU, the H2D and the H2C are a good fit. But for the middle ground, I'm not sure the P2S makes much sense anymore at its current price point. If for $100 more, you can get the X2D with a heated chamber and a possibly useful auxiliary extruder, I think that's the way to go. I think that's all I have to say for now. As I said, there's a link down in the description, but be aware that I will earn a commission if you use that to make a purchase. If you found this useful, that's a great way to support the channel. If you like what I do here, you might also want to check out the Clow42 Patreon. Lately, I've been sharing progress on future projects over there, and my amazing patrons have been providing early feedback, and also pushing me to make things more complicated and more awesome than I had initially planned. It's a whole thing. Thank you for watching.